In this video, we're going to look at the evaluation of some miscellaneous integrals. So let's look at the first one here. Got the integral of x multiplied by e to the negative 3x squared power. This one's going to be a simple substitution here. Let u equal to the exponent here of minus 3x squared. Then du will equal to the derivative of minus 3x squared, which would be a minus 6 x dx. So let's put the x dx together here. Divide both sides of this by a negative 6. This would be a minus du over 6. And replacing the x dx by minus du over 6. And the negative 1/6 goes out in front here. Negative there. And then we got e to the u there. So simple integration with respect to u. Integral of e to the u with respect to u is c to the u. But let's go back to the original variable here. U is at minus 3x squared. The minus there, and a 6, or minus 1/6 as the coefficient, plus the constant of integration. So the answer to the first one here is minus 1/6 of e to the negative 3x squared. There's a minus here. Well, that's the answer for the first one. Now for the second one here, the answer to this one is going to be, see, the derivative of this is 7. This is just be 1/7 of ln of absolute 7x minus 2 plus the constant of integration. So again, basic u substitution. You let u equal to 7x minus 2. Then du would be dx. This becomes a du. This is a u here. And you got it in terms of du, pretty much like number 1. Except the u is in the denominator instead of a exponent. But there's your answer for number 2. There are some shortcuts that you can use anytime you have a constant on top and the denominator is linear or first degree. This could be 7x minus something or plus something or 5x. As long as it's not a square, all it is the absolute value, the natural log of the absolute value of the denominator multiplied by 1 over whatever this constant is. In this case, it's 1/7. But it's a basic u substitution. So again, 1/7 natural log of 7x minus 2 plus the constant of integration. Now for the next one, again, a u substitution. Always take as much as you can when you do a u substitution, if it helps you. And in this one it does. Sometimes you might think of letting u equal to 3x, but here I'm going to let u equal to the whole thing, ln of 3x. Because then du would equal to the derivative of this natural log. And there's just going to be the argument here, 3x, in the denominator. And the derivative of the argument, that's 3x. Derivative of that is 3. So these divide out. Leaves me with 1 over x dx. So this is equal to then the integral dx, but let's do it this way, dx over x, that's right here. That can be replaced by du. So this will be du. ln of 3x, that's your u. So there we have it set it up. Integral of du over u is simply equal to the natural log of the absolute value of u. But remember here u is ln of 3x, so I'm just going to put absolute value of ln of 3x plus the constant of integration. So final answer for this one, ln of the absolute value of ln of 3x plus the constant of integration. Now in the next one, got the integral here, and it's just divide through here by e to the x. So this is the limits of integration. I'm not going to change for this one. I'm going to leave them in terms of x. So this divide through by e to the x. This would be e to the 3x. All I'm doing is dividing each component in the numerator by e to the x. So e to the 4x divided by e to the x gives me e to the 3x minus e to the 2x over e to the x. That reduces to e to the x. The next one is 1 over e to the x. I just write that as e to the minus x. 1 over e to the x, the same thing as e to the minus x. And then this is equal to, now we can integrate. So the integral of e to the 3x is e to the 3x. Using the chain rule in reverse, derivative of 3x is 3, so this gets divided by 3. Minus integral of e to the x. That's just e to the x because the derivative of x is 1. That doesn't change it if I divide by 1. And then same thing for the next one is e to the minus x. In this case, the derivative of minus x is a minus 1, so this becomes a minus here. And then it's going to be integrated. Limits of integration are from 0 to 1, so it'll be 0 to 1. So we evaluate these components here at 1 and then subtract the value at 0. So let me just bring it over here, evaluate at 1. So this would be e to the 3 over 3. All I'm doing is replacing the x by 1. This is going to be minus e to the 1 minus e to the minus 1. We have this. Then it's minus. Now we just evaluated the lower limit, 0. So put a 0 where the x is. 0 there, give me a 0, so it'd be 1/3 here. 0 there, give me a minus 1. 0 for this one, minus 0. So it'll be e to the 0 again is a minus 1. That's what we have. And then this right here, it's a minus 2. There's 2 in here. And then a plus 1/3. That's minus 5/3. But then we have a minus out in front. So that's going to make it a plus 5/3. So let me just do this. This is minus 5/3, and then a minus here. Make this a plus 5/3. And since these are all different, we could actually leave the answer in that form. But if you have a calculator here, or they ask you for an approximation, use your calculator and combine this out, and we're going to get 5.276. So that's your answer to 3 decimal places. Let's clear this. Now let's look at number 5. For number 5, we have e to the x, integral of e to the x over e to the x minus 1. This one again, use substitution. Let u equal to e to the x minus 1. Then du would equal to the derivative of the right side. Derivative of e to the x is e to the x. Derivative of minus 1 is 0, so this is going to be du is equal to that. So you can see here that e to the x dx right here, that's replaced by du. So that the e to the x dx replaced by du, and the denominator is e to the x minus 1, that's your u. And there's a formula again for the natural log. The integral of du over u it's always going to be ln of absolute value of u, but in our case, u is e to the x minus 1. You got plus the constant of integration. Again, most of these are basic u substitutions involving exponentials, log functions, and so forth. So that's your answer for number 5. Now for the next one, notice again, sometimes it's pretty obvious when a u substitution is going to work. Sometimes it's not. But here, this one again is one of the obvious ones, because the derivative of the denominator has an x squared factor. So whenever that happens, as long as it has a constant factor, we can select u to be that. So here the u will be in the denominator again. That u equal to x cubed minus 1. Then du would be derivative of x cubed is 3x squared. Derivative of minus 1 is 0. So we get this. So there's your x squared dx right here. X squared dx. Obviously, so you solve this for the x squared dx, then the 3 comes out over here. Divide both sides by 3 here. So the integral is going to become, and sometimes you can do this in your head, a lot of times, especially on this one. But sometimes your instructor wants to see a lot of the work here. So we can say this is the integral of x squared dx, that'll be du over 3. Put the 1/3 out in front. And then we have the u here. So this again is going to be, still have the constant here of 1/3, and it's the natural log of the absolute value of u. But in our case, we go to the original variable, go back to the original variable, so we just put in, instead of u, put in x to the 3rd minus 1, plus the constant of integration. So that's the final answer for number 6. 1/3 ln of the absolute value of x cubed minus 1 plus the constant of integration. Now notice on this one, on number 7, it's also a u substitution, but this is not an obvious one, because if you take the derivative, say, of x plus 3, you get 1. You don't get the x. But always use your substitution in more than one way. So let u equal to x plus 3, then du would equal to the derivative of x plus 3. That's going to be 1, so we can just say dx here. So now this one we're going to transform the integral in terms of u. Now if you leave it in terms of x like I did in the other one, that was this is a definite integral. You don't have to mess with the limits of integration. But here I'm going to leave it in terms of u, so in that case I have to change the limits. So what we have to do here is, here the x is 0, the lower limit is 0, and the upper limit is 1. So we can say, okay, if x is equal to 0, the lower limit, what would it be with u? Well, I put a u right there, if I put a 0 right there, and u would be 3. At the upper limit, that's a 1, so if x is equal to 1, over here, put a 1 where the x is, 1 and 3 is 4, then the u would be 4. So now we go here. Convert the integral in terms of u. Remember, you can't have any x's. So everything's going to be in terms of u, so the limits have to be in terms of u. So what do we get here? In terms of u, this would be a 3. The lower limit would be a 3 there. The upper limit would be a 4. We need something for the x. But from this substitution here, taking the 3 over, I can see that x is going to equal to u minus 3. So up here where the x is, I just put u minus 3. And then the dx is just du. And then the x plus 3, that's the u, so this used to be u squared. just divide through by the u squared. So I got the integral from 3 to 4 divided out here. This gives me 1 over u, and this would be minus 3 over u. But I'm going to write it, instead of over u, I'm going to write it as minus 3u to the negative 2. And then it's du. So now we integrate with respect to u. So this would be du over u. Well, that's just the natural log of absolute u. Remember, we're leaving everything in terms of u because we have the limits in terms of u. So we got this. And here, I integrate with respect to u, add a negative 1, add 1 to the negative 2, we get negative 1, and divide. That'll give me a plus 3 to the negative 2. Okay, so that's the integration in terms of u. Now we evaluate at the lower limit, the upper limit. So it's the upper limit first. So we replace the u by 4, so this will be ln. Absolute value of 4 is going to be 4, so we just put 4 here. Plus 3. And this was a negative 1 here. This was natural log of absolute u. We got that there. And here we added 1 to this one, so it can be a negative 1, and we divided, so I get plus 3 here by negative 1. Negative 3 by negative 1. So then, again, put a 4 there, we get this, and then to put a 4 here, that's going to be 4 to the negative 1 is the same thing as 1/4. So I can write this as plus 3/4 here. Then it's minus. Okay. Now we go evaluate the lower limit, 3. So this will be ln of 3 plus, put a 3 here. That's 1/3 times 3. That'll be a plus 1 here. So this is going to equal, let me put it up here, equals 2. Let's do these two together here. That's ln of 4 minus ln of 3. Difference of 2 logs, I can write that as the natural log of 4/3. And then I got a 3 over 4 and a minus here. This would be minus 1, so this gives me a minus 1 here and a 3 over 4. That's going to be a minus 1/4. So if they want an exact answer, you can give this. If they want an approximation, you can use your calculator and to 3 decimal places, this would be 0.038. Let's clear this. Now to number 8. I want the integral of 2 over 1 minus sine squared of x. Well, let's just do this. Anytime you're evaluating trigonometric integrals, have the trig functions involved here, use some of your identities. We have one that tells me that cosine squared of an angle plus sine squared of the same angle is equal to 1. Using that identity, you can come up with 1 minus sine squared of x is the same thing as cosine squared of x. So from that, I can rewrite this, have a 2 here, got the cosine squared here, because cosine and secant are reciprocals, I take that to the numerator, that becomes 2 secant squared of x dx. And then you have to know your integrals for the basic integrals for the trig functions. Secant squared has an integral of the constant comes along for the ride, tangent of x plus the constant of integration. And that's your answer for that one. And then there's a lot of formulas, especially in calculus 2 for integrals. Not so much for the derivative, calculus 1, but in calculus 2, when you get into integration, there's a lot of formulas, there's tables. Some the instructor is going to expect you to memorize or to be able to derive it. This one is one involving the arc sign. It says if you have some constant, this could be any constant here, and then the square root of, say, an a squared, and this could be an x or a u. In the formula, it's u squared, like this. And instead of dx, this is du, because sometimes it won't be in this exact form. You'll have to use a u substitution to get it in this form. And it simply tells you that if you have it in the form du over the square root of a squared minus u squared, here I have it as x, then the value of that integral is sine inverse. Sometimes they use arcsine of u, whatever u is. Sometimes u could be in terms of x, 3x, 5x. In this case, it is in terms of x. X and u are the same. Say this is going to be u over a plus the constant of integration. Now, right from this, that in our case, the a is 7 and the u is x. So the answer to this one using this formula would be sine inverse or arcsine of u. In this case, u is x. It's 49 or 7 squared, so the a is 7. So the answer for number 9 is sine inverse or arcsine of x over 7 plus the constant of integration. That's your answer. Thanks for watching. We'll see you next time.